Hello?
So when you're ready, you can start.
Yeah.
Hello, can everyone hear me?
Yeah.
Okay, good morning, everyone. My name is Olivia, and my teammate is Stephane. Our project title is Visual Data Analysis, Analyzing Air Quality in DC. So our abstracted objective is climate change, and more precisely, air quality is one of the major subjects that animate governments and environmental defense organizations. The changes affect our societies in different aspects, such as air quality. With all these changes, air quality in DC has taken a hit due to the emission of gases such as sulfur dioxide and carbon monoxide in the atmosphere, thus putting the health of the population at risk. For the sake of having a clear idea on the concentration rate and their impact on health in the city of DC, we collected data from the United States Environmental Protection Agency from the years of 1980 to 2019 of different chemical components. And we analyzed the data sets using Tableau. And so the reason why we wanted to work on air quality analysis was for us to be able to perform data analysis using Tableau and to get visual aids such as graphs to compare the results that we would obtain. And so this project has really helped us analyze, improve our analysis skills, as well as learn how to manipulate data using Tableau. So our data sets are from the our data set began from the year 1980 to 2019. And so the data set was yearly, it was individual. So we had to merge each data set to make it into one data set from 1980 to 2019. As you can see on the data set summary, we have the 7 components, the years, and the number of rows and columns, and the state that we're focusing on as well. And so one of the things that our data set is focused on is air quality index. And so air quality index is used to report daily air quality and shows how clean air is, and also focuses on whether how the index value affects the environment. So the greater the air quality index value, the higher the risk to the environment as well as to health. And so, can you go back, Stephane, a little bit? And so when we look at our, the air quality index table, we can see how air quality index is measured. So if it's from 0 to 50, it simply means that the air quality is really good and it poses no risk or maybe little risk to human health and the environment. And when it's 51 to 100, then it's moderate. And when it's above 100 to 150, then it becomes unhealthy to sensitive groups. And when it's 200, it's unhealthy. Above 200, it's very unhealthy. And above 300, it's very hazardous.
So in this picture, we decided to focus on the winter time. So in order to do that, we didn't use all the data. So we have to filter the data. So we filter the data. So we used the data from 2017 to 2019. So after we did that, we sorry. So we decided to see which period, which year between those 3 years were had the higher level concentration of nitrogen or dioxide. So the nitrogen dioxide is a chemical component that is highly reactive. It is emitted in the air from fuel. During the winter time of 2017 to 2019, the average concentration recorded was 27.886 per billion. According to the national standard for air quality, the annual average of 2 is 53 per billion. Therefore, 2.7866 PB does affect air quality because it is below the national average of NO2. In these 3 years, air quality index value was good because the concentration recorded of NO2 was below the average. So this graph is for the summertime. Like I said before, we filter the data. We use only data from 2017 to 2019. The summer of 2017 to 2019, the average concentration recorded was 18.158 per billion according to the national standard for air quality index. The annual average for NO2 is 53 ppb. The two graphs show that between winter and summer season, the two graphs shows that between winter and summer season, the average concentration of NO2 was below the national average. The reason why winter has the higher record than the summer is because the time many use the vehicle, and the emission of burning fuel contributed to the higher record. During the summertime, the concentration recorded for NO2 was lower than the winter because if fuel does not drive. So CO2 and SO2. CO2 stands for carbon monoxide and is a colorless and odorless and tasteless toxic gas. It is produced by fuel that contain carbon. SO2 stands for sulfur dioxide. It's a colorless gas liquid with a strong odor. It is produced by burning of fossil fuel. In 1982 had the highest record of CO2 concentration with a total of 2.5 microgram per cubic meter of air. Like we can see in this picture. The orange one, and the higher was located in River Terrace because those data were collected in 4 locations. The first one was Hand Point, the other one was McLean, and Near Road and River Terrace. In 2016 had the highest concentration of SO2 with 282 microgram per cubic meter of air. The lowest record of concentration SO2 with the lowest record of concentration of SO2 with 202 microgram per cubic meter of air. Hence Point had no CO2 and SO2 concentration record. Like we can see on this picture, the blue one. River Terrace is the higher, and then the lowest was Hint Point, so the first part. Lead or PB. Lead, in this picture, we see all the 4 locations where lead were collected. then they collect lead between 1982 to 2015. Actually, we filter the data because the data was very big. So in order to have a good representation, we decided to use only data from 1982 to 2015. So in this picture, lead stand for lead is a small element. It is emitted from industry sources such as mining, smelting, and refined activity. So in 2015, each side had the lowest level of PB concentration. So like we can see on this picture, 2015 is lowest, 2015, 2015, 2015. In, two, in 1983, each side had the highest level of PB. Like in 1983, when the highest was 27, in 1983, in McLean, the highest was 180. In Nero, the highest was 39. In River Terrace, the highest was 282. So, like I said, River Terrace in 1983 were the site with the highest level of lead with 282.795 microgram per deciliter.
So the graph that Stephane just talked about was showing the sum of lead, which was collected on a daily basis. And now the second graph that we're looking at, we decided to measure the mean of lead concentration. Can you go to the next slide, Stephane, please? Okay. So in this graph, we decided to calculate the mean of lead. And so when we look at the graph in 1983, there was the highest record of lead, which was 44.66. And when we looked at the EPA ambient national air quality standard for lead, the mean that is considered to be stable or normal is 0.15. And so this actually shows that during that year, there was a higher rate of lead that was emitted, and it did affect air quality. And when we look at 2019, the mean concentration recorded was 0.19. And so even if it was lower compared to 1983, it was still higher than the national standard, but it actually shows that there was a little bit of progress on the air quality, even if it was a little bit higher. And so the major sources of lead during that time in the 1980s was mainly gasoline exhaust. And so this actually shows that the high level of lead in the air can cause respiratory problems to human health and the environment as well. PM10 and PM2.5, or particulate matter, is actually fine matter. And these two particles have different shapes and sizes and are made up of hundreds of different chemicals. So they're directly emitted from construction sites and paved roads, fields, fires, and smokes. And when we look at the graph, we decided to calculate the daily air quality index that was collected, and this is the sum. And so the highest was in 2006 with a record of more than 20 million. And this is the one we can see in blue right here. This is PM10, and PM2.5 is in orange. It also had the highest record in the same year, which was more than 30 million. And so, I'll go ahead, Stephane.
Mm-hmm. So in this graph, it's a PM 2.5. So in this graph, we decided to calculate the average according to the national standard air quality. For PM2, the average can be calculated in 24 hours, in 1 hour, or in 3 hours. So in order to have the average, we decided to use the 1999 and 2001 and 2017 to 2019. We did that because we want to see if between those years there were a change, there were an increase or decrease of the air quality index value. So after we did that, we found that between 1999 to 2001, the air quality average was 57 UMG per cubic, and between 2017 to 2019, the average was 37 or 35, sorry. So comparing the two average year, there has been improvement in air quality. Between 1999 to 2001, the average for PM10 concentration. When we say PM10, because the previous slide is the continuation, this slide is also the continuation of the previous year. So between 1999 to 2001, the average for PM10 concentration was 60. 2017 to 2019, the average over 3 years, like I said, we use 3 years, like the interval of 3 years. So in 2017 to 2019, the average was 8, which was below the national standard for PM2 over 3 years. The PM 2.5 concentration was high because it was surpassing the annual standard for PM 2.5, which is 12, the average over 3 years. When PM 2.5 is at the higher rate in the atmosphere, it can cause short-term effects such as eyes, nose, throat irritation. Yeah, do you have something to add?
No.
Any questions?
Questions, please.
Did you guys explain what PM was? I might have missed it.
It's particulate matter.
Oh, okay.
And it's just that one is 2.5 and the other one is 10 because they have different sizes, but they're actually small particles which have different sizes, really. So it's actually the same particle, but of different sizes.
Oh, so it's just like is it like a particle of like CO2 or something?
Not really. Because the main difference between PM10 and PM 2.5 is the size. So PM10 is bigger than PM 2.5. That's the big difference. But they are the same particle.
Gotcha.
So could you explain the final conclusion about your work? So after you performed, you did some kind of environmental data analysis and about the DC region. So then, right. So what is going to be the DC region environmental components, right? So is it going to be getting better, or do we have to worry about something else, or what? Could you add that narrations?
Yeah. When we were doing our project, so we discovered that, so according to the APA, like Olivia mentioned at the beginning, now more people are worried about the environmental health situation because they don't want to be sick. They don't want to they don't want to have cancer because the lack of the ozone. So in in the previous years, the quality of air in DC was very bad. But starting at, I think, 2006, according to the APA, the air quality starting getting better because they put in place many regulations, many laws. Like, for example, they put a fine that you cannot emit at such level of, I'm talking about, for example, the industry of cars industries, construction industries. They have to follow certain rules in order to be admitted in DC. So that's one reason why now the air quality in DC, or the air quality index in DC, is very good. It's getting better and better. Even though sometimes, especially during the summertime or the winter time, it depends. Sometimes it's good, sometimes not better. It's better because, like, in the summertime, people, they don't like to use the cars. They like to walk, run out, uh, participate to the activities like running, like go to the movie theater. But during the winter time, the air quality can be bad because we are using AC because it's cold. We wanna like get warm. We put AC. The AC like produce the CO2 and then the NO2. And also many people are using the cars because they don't want to work because it's freezing outside. Yeah, that's it depends, but overall, the air quality in DC is very good.
All right, thank you. So let's move on to the next presentations. All right.